So yes, welcome. So this is lecture number 20, right? Lecture number 20 in ordinary differential equations, right? Yes. So far I have already uploaded 19 lectures. So this is 20th lecture, right? This is 20th lecture, and we are going to start type 5. That is the last 10 videos we have been solving the problems based on second and higher order differential equation with constant coefficients, right? So this is the topic we are discussing for the last 10 videos. So far we have completed type 1, type 2, type 3, type 4, right? So just recall that we will have a second order differential equation, and it will be a constant coefficient, and RHS we will have different. So what in type 1 we will have RHS is of the form e power ax, right? You just recall all the types that we have already seen and discussed. And type 2 RHS is of the form sin ax or cos ax, right? RHS is of the form sin ax or cos ax. And type 3 we have seen RHS is of the form x power n, and in type 4 we have seen RHS is of the form x power some e power ax into b, and this b can be x power n, or b can be sin ax, or b can be cos ax. So this is type 1, type 2, type 3 and type 4, which we have discussed earlier, right? So if you haven't watched that video, please watch that videos and then come back to this video, right? Yes. So now we will be moving on to type 5, that is RHS is of the form x into v. You can see type 4 is e power ax into b. Now we are going to solve when RHS is of the form x into b, right? X into b. So for example, the problem will be like d square plus 1 of y is equal to x into sin x, right? You can see x into b, and this b can be sin ax or cos ax. B can be sin ax or cos ax, right? So this will be a question, right? X into b, and this b can be sin ax or it can be cos ax, and here it can also have x square into b also, right? It can be x into b or x square into b, right? Yes. So first we will discuss when RHS is of the form x into b, and this b is sin ax or cos ax, right? So type 5 x into sin ax. Suppose if we have e power ax into cos ax, that will be in type 4. So in type 5 we are going to discuss x into sin ax or x into cos ax, right? So we are going to follow same method for finding complete. We are going to find a characteristic function. The particular integral, it will be different, right? Particular integral will be different. So we'll move on to the first problem now. The first problem is, so there are two ways to solve these types of equation. That is, there are two ways to solve a type 5 equation, that is RHS is of the form x into v. So I'll write it down. There are two ways to solve this equation. So first method is by using the formula, right? The first method is using the formula. So I'll write down the formula now. The first method is using the formula, right? So for finding particular integral, we can solve in two ways, right? First way is using the formula, right? So there are two ways to solve this type of equation. One is using the formula and another is by using a proper substitution, right? So we will discuss more. So using formula, so particular integral can be found by using the formula. Suppose if RHS are the form x into b, then the formula for finding particular integral, that is 1 by f of d into xb, right, into xb is equal to x into 1 by f of d into b minus f dash of d divided by f of d whole square into b, right? So in order to find particular integral, you can use this formula. You can use this formula, or you can also use some substitution method. So you just mug up this formula, right? So particular integral will be 1 by f of d into xb. F of d is the function that they are given the question. So x into b. So if you substitute this formula, and we need to use type 2 or type 3 based on the question they have given, right? So first we will solve one problem, then it will be very easy for you, right? So first problem is, so when we see problem, it will be very easy, right? So make sure that you have watched all videos from type 1 to type 4, then only you can understand this video, right? So problem 1, right? Solve d square plus 9 of x, d square plus 9 of y is equal to x into sin x. Now you can see this comes under type 5, right? Why? Because type 5 RHS is of the form x into v. Here v is sin x, right? Yes. So type 1 will be e power ax, type 2 will be sin ax or cos ax, type 3 will be x power m, type 4 will be e power ax into x, and type 5 is x into sin x, or it can be x square into sin x, it can be anything, right? So it will be a multiple of x, right? So what is the general solution? The general solution is y is equal to cf plus pi, that is complementary function plus particular integral. So for finding complementary function, we need to follow the same method that we did for all the previous types. So for finding complementary function, so to find CF, right? So first we need to find CF. So for that we need to write auxiliary equation. So these are very easy and elementary, which we have discussed in previous videos, right? So what is auxiliary equation? So that is m square plus 9 is equal to 0. So whatever we have within y, we need to make that to be equal to 0. We need to find the roots. So depending upon the roots, we need to write the complementary function. That means this is equal to m square is equal to minus 9. This implies m is equal to square root of minus 9, which is plus or minus 3i, right? That means the roots are imaginary, right? Roots are imaginary. So we know when the roots are imaginary, what is our complementary function? So our complementary function is e power alpha x into a cos beta x, or c1, you can write any constants. So c1 cos beta x plus c2 sin beta x, right? When the roots are imaginary, the complementary function is e power alpha x into c1 cos beta x plus c2 sin beta x. So you can see this is of the form alpha plus or minus I beta. So in our case alpha is 0, right? In our case alpha is 0 and beta is 3, right? Alpha is 0 and the beta is 3, right? You can see alpha plus or minus I beta. So beta is 3, alpha is 0. So therefore what will be our complementary function? So we just substitute alpha to be equal to 0, beta to be equal to 3. So this will be e power 0x. So e power 0 is 1. So we will have c1 cos 3x plus c2 sin 3x plus particular integral. Now we need to find particular integral, and then we can substitute here to find the general solution, right? Yes. Now we need to find particular integral. So how can we find particular integral? So I have already given the formula for you. When the RHS is of the form x into v, we are going to use that, we are going to make use of that formula, right? So as of now we will erase this. So we have found complementary function. Now we need to find particular integral, right? So what is particular integral? 1 by d square plus 9 into x sin x. So again we are following the same method up to now for all the types, right? So if it is only x, we will go for type 2 or type 3. If it is only sin x, we will solve this using type 2. How we solve type 2? We will replace d square by minus of a square, and then we will substitute here. If the denominator is 0, we will multiply x, and then we will differentiate the denominator. Again we will substitute d square is equal to minus of a square, right? So we just recall all the types. Now here you can see our particular integral is x into v, right? So x into v. So what is the formula I have given? So formula, we know the formula is when the particular integral is of the form 1 by f of d xv. So here f of d is d square plus 9, x is x, v is sin x. So what is the formula that I have given? X into 1 by f of d into v minus f dash of d divided by f of d whole square into v, right? This is the formula I have given. Now we can make use of this formula now. So this is equal to, so you just think of d square plus 9 as f of d and v as sin x. This will be x into 1 by f of d. So d square plus 9 into sin x, right, minus f dash of d. What is f of d? Or f of d is d square plus 9. F dash of d will be 2d plus 0, right? D square is 2d, 9 is 0, divided by f of d whole square. So will be d square plus 9 whole square into sin x, right? So I'm just substituting using this formula now. Now you can see this, we need to solve this using type 2, right? Type 2. So 1 by f of d into sin ax, and again we need to solve this using type 2. So we can see the type 5 problem is now reduced to type 2 when we use this formula, right? Yes. So this will be x into 1 by d square plus 9 sin x minus 1 by, so I'll keep 2 as it is. So d square plus 9 whole square d of sin x. So d means differentiation, 1 by d means integration. So d of sin x, that is derivative of sin x, is cos x, right? So x into 1 by d square plus 9 sin x minus 2 by, so I'll mark this as pi1 minus pi2, right? So pi1 is 1 by d square plus 9 sin x, and pi2 is 2 by d square plus 9 whole square into cos x. Now we will solve pi1 and pi2 separately, and then we will substitute here to find the particular integral, right? So we are solving a second and higher order differential equation constant quotient, that is we can see d square. What is the quotient? It is 1, which is constant, right? Yes. So what is pi1? So pi1 is 1 by d square plus 9 into sin x, right? So this is type 2 now. So how we will solve type 2? So type 2, that is we will replace d square is equal to minus of a square. So what is a here? A is 1 because sin ax, a is 1. That means we will replace d square by minus of 1 square, which is minus 1. So this becomes 1 by minus 1 plus 9 into sin x. This will be 1 by 8 sin x, right? Suppose if this turns out to be 0, we will multiply x, we will differentiate denominator, and then we will operate once again. But since it is not 0, this is our pi1. So what is pi2 now? So pi2 is 2 by d square plus 9 whole square into cos x. So again you can see this is type 2 integral because this is RHS is of the form sin ax or cos ax. Now again we will replace d square by minus of a square. So this turns out to be 2 by, so d square is equal to minus of a square. So this will be minus of 1 square, which is minus 1. So it will be minus 1 plus 9 whole square into cos x. So this will be 2 by 8 square. So 8 square is 64 cos x. This will be 1 by 32 cos x, right? So you can see we have found PI1 and we have found PI2. Now we'll substitute here. So we will mark this as equation number 1, or we'll mark this as equation number 2, right? So we will substitute in equation number 2 to find the particular integral. So what is particular integral? Pi. So from 2 x into Pi1 minus Pi2, right? X into Pi1 minus Pi2. So this turns out to be, so x into Pi1. So what is Pi1? It is 1 by 8 sin x minus Pi2 is 1 by 32 cos x, right? 1 by 32 cos x. So this is our solution now. So sin x by 8, yes, x into sin x by 8, or you can also take 1 by 8 common. So it will be x sin x minus 1 by 4 cos x is our particular integral. So what is the general solution? The general solution is y is equal to Cf plus Pi. So what is Cf? We already found. This is C1 cos 3x plus C2 sin 3x plus what is particular integral now? So it is 1 by 8 x sin x minus 1 by 4 cos x, right? This is our general solution. Right? Yes. Now what we will do is, we will do this in another method, right? So in the beginning of the video I have said we can solve this method using two method, that is we can find particular integral in two method. One is by using the formula, that is the formula which is x into f of d. We can solve this using in the beginning of the video I have said we can solve the particular integral using two formula. One is by using the formula that I have mentioned, 1 by f of d xv is equal to x into 1 by f of dv minus f dash of d divided by f of t whole square into b. And another is we can also solve this particular integral using substitution, right? So I will solve the same problem using substitution, right? Using substitution. So we will arrive at the same answer, right? That is, I am going to find particular integral by not using the formula, right? So what is the particular integral? 1 by d square plus 9, I think it is 1 by d square plus 9 x sin x, right? So far we have already got the answer using the formula that I have given, 1 by f of d xb is equal to x into f of d, x into 1 by f of dv minus f dash of d divided by f of d whole square into b. Now we are not going to use the formula, so we are going to use some substitution to convert this into type 4. What is type 4? Type 4 is e power ax into x, right? So I am going to make some substitution here to transform this particular integral to type 4. So how I am going to write this is, I am going to write this as imaginary part of 1 by d square plus 9 x into e power ix, right? So what is e power I theta? E power I theta is, so what is e power ix? This is cos x plus I sin x, right? Cos x plus I sin x. Here you can see we have only sin x. That means I can write sin x as imaginary part of e power ix. Suppose if I have cos x, I can write that as real part of 1 by d square plus 9 x into e power ix. So since we have sin x here, I can write this as imaginary part of, so I am just replacing sin x by e power ix. Suppose if I have sin 2x, I will write that as e power I 2x, right? Yes. So I am going to solve this equation using type 4 now. So you can see this is type 4, e power ax into x. So how we will solve this equation? So imaginary part of, So in order to bring e power ix to front, what you will do? You will replace d by d plus I, right? So you can see type 4. You just recall how we solve type 4. So type 4 will be when r is the sum of e power ax into v. Suppose if I have 1 by f of d x into e power ax, what you will do? You will, we can bring e power ax outside. Now we need to replace d by d plus a, right? We need to replace d by d plus a. You just recall all the videos that we have given earlier. That means here we need to replace d by d plus a. Now we can use type 3 to solve this equation. Now here you can see our a is I. That means we need to replace d by d plus I. So I can take e power x outside. This will be 1 by d plus I whole square plus 9 into x, right? Now you can see this is a type 3 equation. Type 3 equation, you just solve this using type 3 and then substitute here, and then you just equate real part, you will get the answer, right? Yes. So we will mark this equation as 1, right? So consider, I'm just going to consider only this case, that is 1 by d plus I whole square plus 9, right? 1 by d plus I whole square plus 9 into x. So I'm going to solve this using type 2. So again, it's a very easy problem. So you just expand this. So it will be a square plus b square plus 2ab plus 9 into x. So this will be 1 by d square. So you can see I square is minus 1. So 9 minus 1 will be 8. So we will have plus 2id plus 8 into x. So we just recall how we will solve this problem. So I'm taking 8 common. This will be 1 plus d square plus 2id divided by 8 into x, right? So this I can write this as 1 by 8. This I can write this as 1 by 8. 1 by 8. This will be 1 plus d square plus 2id divided by 8 whole power minus 1 into x. So I'm just using type 2 integral now, right? Type 2 integral. So you just note it down the answer. So the particular integral, we need to get this as answer, right? It is 1 by 8 x sin x minus 1 by 4 cos x. That is the answer we need to get. So I'll erase this off. This is the answer that we got using the formula, right? Now we are going to use another method to arrange the same formula. So this I can write this as, so this is 1 by 8. So again 1 plus x whole power minus 1, right? So 1 plus x whole power minus 1 is 1 minus x plus x square minus x cube and so on. So you can see here it is a first order, right? That is the degree is 1. Degree is 1. That means it is enough to write only 1 minus x, 1 minus x plus x square. It will go on, so it will go on. But since we have x, d square will be 0, right? D means derivative. So if we differentiate once, we will have 1, and if we differentiate twice, it will be 0, right? So we can omit all the terms that are higher powers, right? So we can omit all the terms into x, right? So you just multiply x inside. So it will be 1 by 8 x minus, so if I multiply this, we have d square by 8 into x minus 2id by 8 into x, and all the terms will be 0 because all of the terms are of degree d square, right? So again this is also 0 because d square of x, so d of x is 1, d square of x is 0. So we will have only this term and this term. So this will be 1 by 8 x minus, this will be 4. So we will have minus id by 4 into x, right? So this will be 1 by 8 x minus, so d of x, that is derivative of x, right? So d of x is 1, so we will have I by 4, right? So that means I by 4 will remain as it is, d of x is 1. So you can see this part, that is 1 by d plus I whole square plus 9 of x is reduced to this part, right? That is 1 by 8 x minus I. So we will mark this as 2. Now we will substitute 2 in 1. We will substitute 2 in 1. So substitute 2 in 1. So this equation turns out to be imaginary part of e power ix. In place of this entire term, that is 1 by d plus I whole square plus 9x, I am going to substitute 1 by 8 x minus I by 4, right? X minus I by 4. So this will be imaginary part of, so we multiply e power x inside, you will have 1 by 8 x into e power ix minus I by 4 e power ix. So we will replace e power ix to be cos x plus I sin x. So it will be x by 8 cos x plus I sin x minus I by 4 cos x plus I sin x, right? So I'm just going to equate only imaginary part, because imaginary part of this only sin x, right? So what happens if I equate only imaginary part? So you can see x by 8 cos x is real part. Suppose if the question is x into cos x, the same method up to this. So instead of equating imaginary part, we will equate real part, but here it is imaginary part. So what is imaginary part? This will be imaginary part, because here we have I term here. So what is the coefficient? It is x by 8 sin x, right? This is imaginary part, and here also we will have imaginary part, right? Minus I by 4 cos x. This will be real part, because I into I will be I square, which is minus 1. So here we will have minus cos x by 4, right? Minus cos x by 4, right? E power, okay, here you have 1 by 8, right? Sorry. So if multiply 1 by 8 inside, it will be 1 by 32, sorry. Right? So again you can see we got the same answer, right? So if I take 1 by 8 common, this will be x sin x minus cos x by 4. So you can either use this method or this method. You can see the particular integral turns out to be same, 1 by 8 x sin x minus cos x by 4, right? So we will do one more problem. So second problem is, so just go through once again, you just take complete notes so that it will be easy for you, right? So now we'll do one more problem now. So we move on to the second problem. So you can either use, for finding particular integral, you can either use a formula, or you can use real part of or imaginary part of, depending on sin ax or cos ax. So we will move second problem now. So solve d cube minus 1 of y is equal to x sin x, x into sin x, right? So again see, again this is type 5, right? Because we will have x into v, here v turns out to be sin x, right? So we will find this. So what will be general solution? So general solution is y is equal to cf plus pi. Cf is the complementary function and pi is the particular integral. So first we will find cf, right? So for finding cf we need to follow the same method that we did for all the types, right? So first we will find cf. So that means we need to find auxiliary equation, which is m cube minus 1 is equal to 0. That means m cube minus 1. So you just use the formula a cube minus b cube. So it is a minus b, a square plus ab plus b square is equal to 0. So this implies m minus 1 is equal to 0 or m square plus m plus 1 is equal to 0. That means m is equal to 1 or, so we just solve this equation. It's a quadratic equation, right? So we just use the formula minus b plus or minus square root of b square minus 4ac by 2a. You will have the roots to be equal to minus 1 by 2 plus or minus I root 3 by 2, right? So just make use of the formula. So m is equal to minus b plus or minus square root of b square minus 4ac by 2a. So you can see our a is 1, b is 1, c is 1. So it will be minus 1 plus or minus square root of 1 minus 4 divided by 2. So this will be minus root 3. So which I can write it as I root 3 by 2. That means the roots are 1 and minus 1 by 2 plus I root 3 by 2 and minus 1 by 2 minus I root 3 by 2, right? Yes. So you can see one is real and another is imaginary. That is 1 by 2 plus or minus I root 3 by 2. So one is real, second is of the form alpha plus or minus I beta, right? So I already discussed how to find the complementary function when one is real, another is, so this will be e power ax, that is you write some constants. So c1 e power m1x, so it is 1 into x, and these two are imaginary, so it will be e power alpha x into c2 cos beta x plus c3 sin beta x, right? So this will be c1 e power x. Why I am writing 1 into x? Because it is 1. Suppose if I have 2, I will write 2 into x. Plus alpha is minus 1 by 2. So we will have e power minus x by 2, right? Alpha is 1 by 2 into c2 cos, our beta is root 3 by 2. So we will have root 3 by 2x plus c3 sin root 3 by 2x. This is our complementary functions, right? That is c1 e power x plus e power minus x by 2 c3 cos, or we will write c2, right? So c2 cos root 3 by 2x plus c3 sin root 3 by 2x. So you just note it down. I am going to erase it. Now I am going to find particular integral, right? So again you can find particular integral using the formula, or you can also write this as imaginary part of x into e power ix, right? But I am going to use formula now. So we have found complementary function. Now we need to find particular integral, and then we need to add complementary function and particular integral. So what is particular integral? 1 by d cube minus 1 into x and x. So again you can see this is type 5. So I am going to use the formula 1 by f of d xb is equal to 1 by f of d into b minus f dash of d divided by f of d whole square into b, right? This is the formula that I have given. So here you can see our f of t is d cube minus 1, x is x and b is sin x. So this will be x into 1 by d cube minus 1 into sin x minus f dash of d. So f dash of d is 3d square divided by f of d whole square. This will be d cube minus 1 whole square into sin x, right? So we will mark this as x into pi1 minus pi2. Now we will find pi1 and pi2 and then we will substitute here, right? So we will mark this as equation number A. So what is pi1? pi1 is 1 by d cube minus 1 into sin x, right? So we need to replace d square by minus of a square. A is 1, so it will be minus of 1 square, which is minus 1, right? So this equation turns out to be, I can write d cube as d into d square minus 1 into sin x. Again you can see we already solved these types of problems in type 2 integral. If you haven't watched the previous video, you please do watch the previous videos on ODE. So this means I can write this as in place of d square, I'm going to replace this by minus 1. This will be minus d minus 1 sin x, right? In place of d square, I'm just substituting minus 1. This will be minus d minus 1. So this will be, if I take minus common, it will be d plus 1 sin x, right? Minus, if I take minus common, it will be minus 1 by d plus 1 into sin x, right? So we need to solve this equation. So how we will solve this equation if I have d? So if you have watched the previous video, what we will do? We will take conjugate, right? What is the conjugate? It is, we need to multiply by d minus 1 divided by d plus 1 into sin x. So this will be minus, we have common, so it will be d minus 1 sin x divided by a square minus b square, right? D plus 1, d minus 1 is d square minus 1 square into sin x. Now again you replace, so this will be minus d of sin x minus sin x, right? I'm just multiplying sin x inside divided by, so instead of d square, I'm going to replace again by minus of a square, so which is minus 1, so it will be minus 1 minus 1. So this will be minus 2, so minus 2 minus will be plus 1 by 2, d of sin x, so derivative of sin x is cos x, this will be minus sin x. So 1 by 2 is, sorry, PA1 is 1 by 2 cos x minus sin x, right? So PA1 is 1 by 2 cos x minus sin x. So instead of PA1, I'm just going to write this as x into, in place of PA1, I'm going to use 1 by 2 into cos x minus sin x. Now I need to find PA2, right? After finding PA2, we can substitute here, then that will be my partial integral, and if I add complementary function to that, it will be my general solution. So again I will repeat, if you have watched the previous video only, then only you will understand this video, right? If you straight away watch this video, it will be difficult to follow, right? Now we need to find PA2. So what is PA2? So PA2 is 3d square, you can see PA2 or PA2, d cube minus 1 whole square into sin x, right? So this will be 3 by and d square of sin x, right? D square of sin x. So what is d square of sin x? So d of sin x is, derivative of sin x is cos x. Again we need to find d, so d of cos x is minus sin x. So this turns out to be minus sin x divided by, so I can write this as d into d square minus 1 whole square, right? So you can see d square of sin x, that means we need to differentiate sin x twice. If we differentiate once, it will be cos x. If we differentiate another time, it will be minus sin x. So d square of sin x is minus sin x. Now again you can see this turns out to be minus 3 divided by d into d square minus 1 whole square into sin x, right? So again you will replace d square is equal to minus of a square. So if I do that, this will be minus 3 divided by, so we replace d square by minus of a square, which is here minus of 1 square, which is minus 1. This will be minus d minus 1 whole square into sin x, right? So this turns out to be 3 divided by d plus 1 whole square, right? So d plus 1 whole square. D plus 1 whole square, right? This is d plus 1 whole square. So if I take minus common, it will be d plus 1, minus of square will be plus square into sin x, right? So this will be 3 by d square plus 2d plus 1 sin x, right? So we will replace d square to be minus of a square. So again it will be minus 1. So this will be 3 divided by minus 1 plus 2d plus 1 sin x, right? So this and this will get cancelled. So we have 3 by 2 into 1 by d of sin x. You can see minus 1 plus 1 will get cancelled because d square is minus of a square. So this will be minus 1 plus 1 will get cancelled. So we have only 2d, right? That means we need to integrate. If I have d of sin x, we need to differentiate. If I have 1 by t, it means we need to integrate. This will be 3 by 2 integration of sin x. So 3 by 2 integration of sin x is minus cos x. So this will be, here we have minus, right? Minus, 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 and this will be plus 3 by 2 cos x, right? Plus 3 by 2 cos x. So what will be my, so pi2 turns out to be 3 by 2 cos x, right? So we'll just substitute this pi2 here. So this becomes, x into 1 by 2 cos x minus sin x minus, so instead of pi2 I'm going to write 3 by 2 cos x. This is our particular integral. So what will be the general solution? General solution is y is equal to cf plus pi. So we already found cf, right? That is c1 e power x plus c e power minus x by 2 cos root 3 by x plus something. You just add up that entire term with this. That will be my general solution, right? So we will solve more problems in the next class, right? So we'll see in the next video. Goodbye. Thank you.